Hello, this is another Mohr's circle example. This one, tension and compression, example number 2. On the vertical surface we have 400 megapascals in tension. The horizontal surface we have 300 megapascals in compression, and then a shear of 200 megapascals. So, it's 400 in tension, it's 200 counterclockwise. That's because you look here in this direction, it's trying to turn it counterclockwise, and 300 in compression. And yeah, that lines up. So now to get the 2 points. So looking at your vertical surface, it's 400 tension, so it's positive. 200 counterclockwise, so it's negative. 300 on the horizontal, but it's negative because it's compression. And if you look here for the shear, it's trying to turn it clockwise, so it's positive. So then you can plot those 2 points, and it's time to get your the sigma value of the center, and then calculate the radius, where you can see here these are the equations that you will use for this. Now, just plugging in to those equations, you should get center value of 50 and the radius of 403. Okay, so this is our circle. Now P1, P2, P1 is going to be on the far right, P2 on the far left, tau P, theta P going from the vertical point to P1, tau max. Now because this is a tension and compression example, tau max is the same as tau P. If this was a compression and compression, or tension and tension, it would not be the same as the principal shear, so you would have to calculate them separate. Here, they're the same value. So your equations, as you can see visually, you can see, okay, here's the center of a circle, which you have the value of. Positive 1 radius to the right, you have P1. To the negative the radius to the left, you have P2. So really you could take 50 plus 403 is P1 and 50 minus 403 is P2. Here is the equations for that, and you can see exactly what I just said. So using those equations, you should find that your sigma P1 is 453, P2 is negative 353, a tau P, it's just directly up 1 radius, it's the same value as the radius, 403. That means tau max is also the same, so it's also 403. Now, calculating your theta P, you go from the vertical point towards P1, remembering that on here visually it's twice the angle, so you have to divide it by 2, where here you can see it's going to be this case. So you can use this equation, find alpha, divide alpha by 2, and you get theta P, where in this case it is actually counterclockwise, so it will be positive, and that value should be 15 degrees. And there you have it.